All right, so we are going to talk about classifying rational and irrational numbers. This is just a lot of vocab. There's no way around it. You're going to have to memorize them. Again, there's no way around that. So just try your best. Okay. Okay, what happened? So looking at this chart, um, for all purposes that we're going to have, we're going to say that all numbers are real. So at the top of this, we're going to say all numbers are real. And then they branch into two sections. They branch into rational or irrational numbers. So it branches, and then rational numbers go down into integers, whole numbers, natural numbers. So it's like a branch. If it's one of these, it's everything above it. Okay. So let's start at the very bottom. Natural numbers are things you can count to on your fingers. Okay, so count to. I spelled count wrong. Embarrassing. Um, okay, so like 25 if I really wanted to. I could count all the way up to 1,000,000. So 145, 873, right? So anything you can count to, I could really count all the way up to that. So just think of it as really any positive number. Okay, so any positive number you can think of. Whole numbers are 0 and natural numbers. Okay, so the only difference between natural numbers and a whole number is that now we're adding 0. Okay, then we go into an integer, which is what we've been really talking about all year for the most part. So integers are positive and negative numbers. Okay, so positive and negative whole numbers, really. So this could be negative 27, 0, obviously, and like 96. Okay, so negative numbers, positive numbers, 0, all of those are integers. So far, we've only talked about whole numbers, things that don't have decimals or fractions. Now, that's where rational and irrational comes into play. It could be one or the other, right? So let's talk about what makes a rational number. So a rational number is a fraction. So anything that is a fraction is a rational number. And I normally say if it's fractional, it's rational. So fractional, rational. So all fractions. Okay. Um, Fractional, rational, any fraction you see for the most part is going to be a rational number. It could also be repeating decimals and terminating decimals, and we'll talk about what those are. And obviously integers, which then makes it a whole numbers. And then natural numbers. So it's all the things. If it's natural, it's whole, integer, rational. If it's fractional, it's rational. If it's a repeating, terminating decimal, it's rational. So fractions, right? Like 5/6. That's a fraction. So is negative 8 and 1/5. Even though it's a mixed number and it's negative, it's still a fraction. So fractions mean rational numbers. Repeating decimals are most commonly you'll see something like 0.3, right? 1/3 as a decimal is 0.333333333. That's repeating. It never stops. Okay. Terminating. When you're thinking of the word terminate, maybe you're thinking of the word end. So terminating means an ending decimal, right? It stops, it ends. So 0.32. That's an ending decimal. It stops. 0.5. Sorry, hold on. Negative 1.6245. That's an ending decimal. Okay, so fractions any fractions, positive or negative, decimals that are repeating, and terminating positive or negative. Okay, so those are rational, plus integers, whole numbers, natural numbers. Irrational numbers, I think, are the easiest to kind of figure out. They are non-repeating and non-terminating decimals. There's a famous one, a famous non-repeating, non-terminating decimal is pi, or something like negative 2.64783 ... The ... tells you that it doesn't end, and none of those numbers repeat. So that's a non-repeating, non-terminating decimal. Also, non-perfect roots. So something like the square root of 85. Is that listed on your half sheet of paper anywhere under the x squared row? The answer's no. Or like the cube root of 144. That's 144 is listed under squared, but it's not listed under cubed. So it's a non-perfect cube, which means it's irrational. Okay. Okay. So there you go. That's that. So use your chart. We're gonna go down here, and we are just figuring out things if they're rational or irrational. So again, remember, rational means fractional, and it's repeating and terminating. Okay, so looking at this first one, it's 0.15 with that bar over top. That bar means it's repeating. So this is rational because it's repeating. And it's also real because all numbers are real. So we're going to list out all the things. So it's rational and real. The next one you have to figure out, is it a perfect square? So is it listed under your x squared column? So look at that quick. Is it listed under the x squared row? The answer is no. So if it's not, it's irrational. And it's irrational because it's a non-perfect root. And if it's irrational, it's also real. All right. Can you try the next one on your own? So take a moment. Try the next one on your own. So I see a fraction, which fractional equals rational, right? So it's rational because that equals fractional. Whether it's positive or negative, it doesn't matter because it's a fraction. So it's rational and it's real. All right. Let's go to the back. On the back, it says classify. When we say to classify something, that means to give as many categories as possible. Okay. So we want to give it all the possible categories. So that means when it's one thing, it filters up to the other, right? So looking at this, I see a negative whole number. I see something that's negative and it's a whole number. So negatives come into play at integers. And that's because it's negative. And if it's an integer, that means it's rational. And if it's rational, that means it's real. So it's all those things. So it's an integer because it's a negative number. It's rational because it filters up and they're real. Looking at 9. 9, is that something I count to on my fingers? It sure is. So this is natural. It's a whole number. It's an integer. It's rational. And it's real. It's all of the categories. Okay. I see a fraction, and I know fractional rhymes with rational and real. Can you try these next two on your own? Pause the video and try those on your own for me, please. And thank you.